this video, we'll discuss a very important concept related to probability distribution, and that is on random variables. A random variable is a very confusing name. To explain this, let me start with what it is not. So let me write down here what it is not, right? So it looks weird kind of thing, right? So but let it be so. So we're talking about random variable. First we'll understand what it is not. What is not this name is, right? So random, so we should be very clear that it is not random. So the random variables are not random. That is first thing. And then it is not a variable also. So it's not a variable. So don't get really confused from the name random variable. You should have a very clear idea about it. It is not really a variable and it is not really random, right? So now the next question is, after all, if it is not random and if it is not a variable, then what is it? So what is it? So let's try to figure this out now. So my answer to this is that it is a function. Now, what type of function? It is a function. So if you have this thing in your mind that random variables are not really random, okay, and they are not really variables, but they are functions, then it becomes simpler to understand further concepts, right? Now, function of what? It's an obvious question, right? So it is function, and we say function of what? Okay. So that's the next question. Function of what? I know these questions may not make proper grammatical sense, but that's kind of thing it is. So we have understood that random variables are not random, they are not variables, but they are functions. Now, they are function of what? Okay. So we say they are function of a sample space. Now we're talking about probability distribution. So in probability, you have events, right? So let's talk about, we have events, and every event will have outcomes. Correct. So normally what we do is that we say, well, this is the sample space set of outcomes. This is the sample space, the set of outcomes, which you may write with letter S, or you may write omega, or you may say universal set, whatever, right? So we'll use S for the time being. So whenever there is an event, there are a set of outcomes, right? So a lot of outcomes, these outcomes. Now random variable actually associates numbers to these outcomes. So whatever we do here is, that is, now we'll call it a function for the time being. So let me call this as a random function for the time being. Okay, so we say random function is to link or to associate each outcome in the sample space with a real number. So this is what it is. So we define a random function, which is actually the random variable. These two are same things. Okay, we are saying we're calling it as a random function to understand, and then we just switch over from function to variable whenever required, right? So random function is to associate each outcome in the sample space with a real number, right? So that is how we create a function, right? So let me give you a concrete example. Okay, let's talk about an example now. So in the example, let's take tossing of coins. Let's say we have 2 coins, okay, and we just toss them. So what are the possibilities? So in this case, what is the possible outcomes? Possible outcomes could be 2 heads, could be head, tails, tail, head, or 2 tails, right? So in our space, we have these 4 countable discrete outcomes. Do you understand? So we are using those terms, and soon we will get into getting used to these terms in more liberal sense. So example, 2 coins are tossed, and then we have 4 outcomes, possible outcomes. You could get 2 heads, you could get head or a tail, tail or head, or 2 tails. These are 4 possible outcomes when you toss 2 coins. We are considering 2 fair coins. Okay. Now how to define a random variable or a function in this case? Now we say, well, let's define a random variable for this count of a outcome. So as I said, random function is to associate each outcome in the sample space with a real number. So what we do is we designate the name of the function. Now first thing is name of the function. So we write name of the function as a capital letter. So name of function, or you can say name of random variable, right? So we'll keep these terms going.